In chapter 26, you're going to be learning about acid-base balance. So I want to share some tips and tricks to help you understand acid-base balance abnormalities. First of all, acids donate hydrogen ions, which are also referred to as protons, to a solution. They donate hydrogen ions to a solution, which decreases the pH. In other words, the pH becomes more acidic. Bases, on the other hand, are referred to as proton acceptors. So they combine with hydrogen ions, they tie them up, effectively removing them from solution, which raises the pH so that it becomes, we can say, less acidic or more basic. And another word for basic is alkaline. The example of a base that we are going to be concerned with is the bicarbonate ion, which is an anion, a negatively charged ion, HCO3. On the pH scale, which ranges from 0 to 14, 7 being neutral, anything less than 7 is acidic, and the lower the pH, the more acidic. Anything greater than 7 is basic or alkaline. And again, the higher the pH, the more basic. So the acidity, again, is due to hydrogen ions. If we look at the balance of hydrogen and bicarbonate, an acidic pH has more hydrogen ions than bicarbonate, and a basic pH has fewer hydrogen ions than bicarbonate, or we can say the amount of bicarbonate is greater than the hydrogen ions. So in chapter 22, you learned about the bicarbonate buffer system. You learned that most carbon dioxide is transported in the blood as bicarbonate. So this equation explains why. I'm having trouble with my pen, sorry. So carbon dioxide enters the blood and it dissolves in water. This forms carbonic acid, H2CO3 is carbonic acid. This is catalyzed by an enzyme called carbonic anhydrase. Carbonic acid is a weak acid that readily dissociates into hydrogen ions and bicarbonate ions. The bicarbonate, again, is our base. The carbon dioxide, or excuse me, the hydrogens that are released are going to decrease the pH of the solution. To prevent the pH from becoming too low, the bicarbonate is going to act as a buffer. Buffers are one or more chemicals that prevent large changes in the pH. So the bicarbonate is going to combine with the hydrogen, and then this reaction is going to occur in the reverse. So that will again form the combination of bicarbonate and hydrogen will form the carbonic acid. And then in the lungs, the carbonic acid dissociates into water and carbon dioxide. The carbon dioxide will be expelled as we breathe out. And when CO2 is eliminated, that will raise the pH of our solution. So in the forward direction, when the reaction proceeds from left to right, it drives the pH down, making it more acidic. And to prevent it from becoming too acidic, then the bicarbonate again will combine with the hydrogen ions and neutralize the pH because the reaction is driven in the opposite direction and CO2 is released. So something you need to understand, and this equation shows you, is the relationship between carbon dioxide, hydrogen, and pH. The more carbon dioxide in our system, the lower the pH. And the less carbon dioxide, the lower the hydrogen ion concentration, and therefore the higher the pH. So now let's look at some of these abnormalities. We talk about respiratory and metabolic acid-base imbalances or disturbances. I'm going to abbreviate respiratory. We're going to look at respiratory acidosis and respiratory alkalosis first, and then we'll look at the metabolic disorders. So in respiratory acidosis, let me back up a little bit because the first thing that all right, Pin. The first thing that you need to know, if you're given a set of values, you need to know the normal ranges before you can determine what the imbalance is. So we're looking here at the pH of arterial blood, which ranges from 7.35 to 7.45. This is a very narrow range. 7.4 is average. Carbon dioxide, its partial pressure is normally 35 to 45 millimeters of mercury. And then bicarbonate is normally 22 to 26. Units are milliequivalents per liter. So by definition, acidosis means that the pH is low. So it's going to be less than 7.35. We're going to indicate that that's low. In respiratory acidosis, the CO2 is going to be greater than 45. Remember, the relationship between carbon dioxide and pH is an inverse one. And then our bicarbonate will be within normal limits if this condition is uncompensated. It will be high, greater than 26, if the kidneys are compensating. So the kidneys compensate for respiratory acid-base imbalances by reabsorbing or secreting bicarbonate to neutralize the pH or normalize it. So in this condition, respiratory acidosis, the CO2 is the cause of the imbalance and the bicarbonate is compensating. In respiratory alkalosis. So alkaline, remember, means basic. Our solution has a high pH. It's going to be greater than 7.45. The cause is the CO2 level. CO2 and pH are opposite, so it's going to be less than 35. So our pH is high. Carbon dioxide is low. Again, bicarbonate will be within normal limits if the kidneys aren't yet compensating. Kidneys take about 3 days before they can start compensating for respiratory acid-base imbalances. But in this case, it will be low, less than 22, if the kidneys are compensating. So in the case of respiratory acid-base imbalances, notice that the compensator, which is the bicarbonate, is going in the opposite direction of the pH. Now, if we look at, let me add an example of respiratory acidosis, any lung condition that causes retention of carbon dioxide, COPD, which includes bronchitis, will lead to respiratory acidosis. On the other hand, respiratory alkalosis can be caused by anything that causes you to hyperventilate, anxiety, stress, fear. You're getting rid of CO2 at a rate faster than it's being produced. So this lowers the level of carbon dioxide. Okay, now we can look at the metabolic acid-base imbalances. I'm going to abbreviate metabolic, and I'm going to abbreviate acidosis. So in metabolic acid-base imbalances, first we look at the pH. And again, by definition, whether it's respiratory or metabolic in nature, if it's acidosis, the pH is going to be low. If it's metabolic, the cause is going to be the bicarbonate. Bicarbonate and pH are directly related. So in metabolic acidosis, it's going to be low. In metabolic alkalosis, our pH is greater than 7.45. And as you might guess, our bicarbonate is going to be greater than 26. The respiratory system, so the bicarbonate is the cause. Respiratory system is the compensator. For respiratory acidosis, we want to bring the pH back up. So the respiratory system is going to expel carbon dioxide. And in metabolic alkalosis, the pH is already high. So remember, if we increase carbon dioxide, we decrease the pH. So it will be high. One of the tricks, if you're given a set of values and you notice that all of the values are either low or they're all high, I'm going to highlight this also so you know what I'm talking about. If all of the values are going in one direction, they're either high or they're all low, that points to a metabolic disturbance. They're all going in the same direction. That tells you that it's either metabolic acidosis if they're all low or metabolic alkalosis if they're all high. Examples of conditions that would lead to metabolic acidosis is diarrhea, prolonged diarrhea over a period of, let's say, 3 days, gets rid of bicarbonate. So that would lead to metabolic acidosis. And if you have prolonged or excessive vomiting, that removes the gastric contents, which are rich in hydrogen. So that will lead to metabolic alkalosis. Now, you might be asked whether or not the condition, the acid base imbalance or abnormality disturbance, is being compensated. One way that you can tell, so look up here again at the respiratory acidosis. We said the kidneys compensate for respiratory acid base imbalances, acidosis, and alkalosis by reabsorbing or secreting bicarbonate. The bicarbonate is going to be within normal limits if the condition is not being compensated. It will be outside of its normal range if compensation is taking place. So if the condition is being compensated, then all of the arterial blood gases, pH, carbon dioxide, and bicarbonate, are going to be outside of their normal ranges. You know, if the compensation is partial, if or because the pH is still abnormal, along with the carbon dioxide and the bicarbonate. But if carbon dioxide and bicarbonate are abnormal, but the pH has been returned to normal, then you know that the imbalance is being fully compensated. Table 26.3 in the e-text has causes and consequences of acid-base imbalances. So you can see what the values will be. All of these are uncompensated in this table. And then you can see some of the causes. So I would expect you to be able to use this table to look up causes of each of the four imbalances. And then there is this closer look. It's called sleuthing, using blood values to determine the cause of acidosis or alkalosis. And it tells you to note the pH first to determine if the condition is acidosis or alkalosis. Then you check the pH, and remember, if it's going in the opposite direction of the pH, if the CO2 is in the opposite direction, it's the cause. If it's going in the same direction, it's compensating. And then they tell you to check the bicarbonate levels. At the end of that sleuthing is this table, which tells you what the values for pH, carbon dioxide, and bicarbonate are for each of the four conditions and what they will be if compensation is taking place. So again, in this table, all of the values are for uncompensated acid-base imbalances. And in this table, they are for compensated. In the module, I gave you a couple of other aids, I guess. I think Rome is explained. So this is a mnemonic, which stands for respiratory is opposite, metabolic is equal, and it's pointing to the relationship between CO2 and pH, which is an inverse relationship. CO2 and pH go in opposite directions, and bicarbonate and pH. So again, metabolic acid-base imbalances are indicated by bicarbonate, which is directly related to the pH. So if we decrease bicarbonate, that will lower the pH. There's a handout that explains the tic-tac-toe method, which you might also find useful in determining the cause of these acid-base imbalances.